Okay, so I just wanted to make a video regarding 30, 60, 90 and 45, 45, 90 triangles. I know there may have been a little confusion about how to use the patterns. So I just want to create a video that you can return to as often as you need to study and hopefully help you memorize these patterns. So in a 30, 60, 90 degree triangle, remember that you have the hypotenuse is your longest side. The side opposite of 30 degrees is going to be your shorter leg because that is the smallest side, and we know it's the smallest side because it's opposite of the smallest angle. That makes the side across from 60 your longer leg. And so remember, these two types of triangles, of right triangles, have specific patterns that only work for these two types. So for this 30, 60, 90, the pattern I'm about to show you only works if the right triangle is a 30, 60, 90 triangle. So how the pattern works for a 30, 60, 90 triangle is that the short leg, and let's just call it X. That short leg can be any length. It could be 1, 2, 1,000, 500. It could be anything. But for now, just to represent that it could be anything, I'm going to say that it's X. To find the hypotenuse of a 30, 60, 90 triangle, I just take the short leg and multiply it by 2. So whatever the short leg is, double it, and you get the length of the hypotenuse in the 30, 60, 90 triangle. If I want to find the long leg, the longer leg, you just take the short leg, which in this case is X, because it could be anything, and multiply it by square root of 3. And so that's the pattern for a 30, 60, 90 triangle. I'm going to do a couple examples in a minute, but I want to make sure that you have the patterns down. So let's talk about 45, 45, 90 triangles now. Now, because your two acute angles, the two 45-degree angles, are the same, that means their opposite sides are also the same. So that means that this leg and this leg are also the same. That makes this an isosceles triangle. So anytime you see a 90-degree triangle, a right triangle, and two sides are the same, number one, you know it's isosceles, but now you know that it has to be a 45, 45, 90-degree triangle. So similar to what we did in the 30, 60, 90 triangle, if this length, I call it X, again, it could be anything. It could be 1, 2, 100, 500, 1,000, could be anything. But if that length is X, because it's isosceles, that must mean the other leg is also X. And since 45, 45, 90 has a specific pattern, the hypotenuse can be found by taking the short leg. I'm sorry, not the short leg. There are no short legs because it's a 45, 45, so the legs are equal. But you can find it by taking the leg, which in this case is X, and just multiply it by the square root of 2. And so those are the patterns of what we call special right triangles. They're special because if you have a 30, 60, 90 or a 45, 45, 90, they follow specific and special patterns. So now let's look at a couple examples. And these examples are taken from section 6.1.2. And so all the examples that require you to use the patterns for 30, 60, 90 or 45, 45, I'm going to do now. There are lots of other right triangles there, but you can solve the rest of them. Any problem I didn't do from this section, you can do by solving, you can solve the missing side by using Pythagorean theorem. So let's look at this first example. Okay, they're giving you that it's a 60-degree angle. So if that's 60 and you already have a 90, this has to be 30, which makes this a 30, 60, 90 triangle. Now, this one, you're given the hypotenuse. Remember that the side across from 30 is your short leg. and then the side opposite of 60 is your long leg. So it helps to remember that the short leg, this side over here, is related to the hypotenuse because the hypotenuse is 2 times the short leg. So what that means is I need to be able to take whatever the short leg value is, whatever that side length is, times 2 to get the hypotenuse. Well, a number times 2 that equals 12 is 6. So your short leg is the length of 6. Now that I know the short leg, I can find the long leg. And it's really simple. You just take the short leg and multiply it by square root of 3. So I'm just going to kind of, quote unquote, attach a square root of 3 to that 6. Leave it as a square root. Don't worry about changing it to a decimal, because leaving it as a square root allows us to possibly see some patterns that we can use later on or for simplifying, something like that. Here's the next one. Now in this one, there's no angles given, but I recognize that it's a 90 degree. It has 90 degrees in it, so that makes it a right triangle. And 2 sides are the same. That makes it an isosceles. Therefore, this has to be a 45, 45, 90 right triangle. If one leg is 3, that means the other leg is also 3 because it's isosceles. Those are the same. To find the hypotenuse, take the leg, doesn't matter which one because they're the same, and multiply it by square root of 2. And you have found all the sides of that triangle. Here's the next one. In this one, you actually are given the short leg right at the beginning. So if I want to find the hypotenuse, using the pattern, I just take the short leg, double it. So in this case, 4 times 2 is 8. So that's the hypotenuse. In order to find the longer leg, I just take the short leg, which in this case is 4, and multiply it by square root of 3. So that one's pretty simple. Now we get to this one. This one's a little bit different. It's a little harder, but not too much. And it relates to the very first problem we did right here with the hypotenuse of 12. This one, we also are given the hypotenuse, but this time it's 13. So we're going to use that 13 to help us find the short leg, which I'm abbreviating as SL. Remember that I need a number for the short leg times 2 to equal 13. So if you take 13 and divide it by 2, you're doing the opposite operation. You get the short leg is 6.5. And then remember, if I have the short leg, I can find the long leg by just taking the short leg, 6.5, times the square root of 3. And I'm just going to leave it in that form. Just leave it with the square root. Here's the next one. Again, I'm giving the short side. It's the side opposite of 30 degrees, so it's the short side. So use that short side. If you double it, times 2, you get the hypotenuse. For the longer side, take the short side, multiply it by square root of 3. And you have all 3 sides. Here's another one where you have a 45-45. Again, you know the leg. You know that the leg is 25. That means that the other leg is also 25. To find the hypotenuse, you take the leg, multiply it by the square root of 2. Okay, here's the last example. And this one's kind of tough. This one's a little bit harder. But you can do it as long as you keep in mind the Pythagorean theorem. So in this case, we have a 45-45. And I know that because it's a right isosceles triangle. 2 sides are the same, and it's got a right triangle in there. Now, I don't know the length of the legs. And in math, whenever we don't know something, most of the time it's best to give it a variable. So I'm going to call this side x because I don't know what it is. If that leg is x, that means the other leg is also x. So what I'm going to do is I'm going to try and solve this using the Pythagorean theorem. So the Pythagorean says one leg squared, so in this case x squared, plus the other leg squared is equal to the hypotenuse squared. And now we're going to just solve it for x to find the missing sides. So x squared on the left side of this, x squared plus x squared is 2x squared, equal to 6 squared is 36. Now before I take the square root, the squared is only attached to the x. So if I want to take the square root, I first have to get x, in this case the x squared, by itself. So what I'm going to do first is I'm going to divide by 2. And I'm left with x squared is equal to 36 divided by 2 is 18. Now that all I have is x squared, I can square root. And so what you get is x is equal to the square root of 18. Now, normally we would be done, but in class we have gone over how to simplify square roots. So I'm going to simplify this as much as I can. Remember, you do this by doing a factor tree. So you can do this as 2 times 9. 9 is 3 times 3. So we can write this as x is equal to the square root, but instead of 18, we can rewrite it as 2 times 3 times 3. And then remember, the rule is if you have a pair, one of those comes to the outside. So in this case, I have a pair of 3's. So x is going to equal, that 3 is going to come to the outside. And since the 2 does not have a pair, it stays on the inside. So it's 3 square root of 2. Another way to think about this is I can rewrite square root of 18 as the square root of 2 times the square root of 9. Square root of 2 is not not a perfect square, so I'm going to leave it there. The square root of 9 is 3, and so I can move the 3 to the front since it's multiplication, and you get the same answer. Hopefully this helps. Hopefully this gives you a better understanding. Again, watch it as many times as you need to refresh. And again, I hope this helps, and hopefully you have now a better understanding of 30, 60, 90, and 45, 45, 90 special right triangles.